let's talk about sulfur containing amino acid. So, point number one, there are two amino acid which contain sulfur. The one is methionine and another is cysteine. Not make mistake in cysteine, it is cysteine. So two amino acid which contain the sulfur, it is methionine and cysteine. Now look at the structure. So the normal amino acid structure, you know that OH group, COOH, hydrogen and R. And this R may be, like if it is CH3, then we call it aniline. If we add oxygen, then it is like CH2OH, then we call it serine. If you add sulfur like CH3HS, then it is cysteine. Okay, so we know the structure of our first amino acid, which is like cysteine. You know the structure CH3HS, which is cysteine. And let's talk about the structure of methionine. Methionine structure is somewhat as large, like R, which contains CH2, CH2S, CH3. So the structure is like somewhat as large, and you can remember that methionine is like essential, so you have to take it from diet. It cannot synthesize in the body because like it has large structure, just for remembering. So sulfur containing amino acid, cysteine and methionine. Cysteine has CH2SH or HS, and methionine has some large structure and it is not synthesized, so you can remember some extra point like methionine, which is essential, and cysteine can synthesize in the body, so it is non-essential. Okay, let's talk about point number 2. I'll now talk about some metabolic portion. So normally in our body we know that methionine is essential amino acid, so you have to take it from diet. So you take a methionine, then methionine is converted into like homocysteine. Methionine is converted into homocysteine. Like what is homocysteine? So if you remove CH3 from the methionine, this is the structure for like homocysteine. Okay, so normally in our body methionine is converted into homocysteine, and homocysteine is converted into further metabolism takes place, and cystathionine, and then there is the addition of serine and vitamin B6. Vitamin B6 is required, and it is converted into homoserine and cysteine. So this is the metabolism. Now let's talk some detail so that you can remember easily. So first, methionine is converted into homocysteine in a body in a normal person. Now what's happened that homocysteine can also converted into methionine. Homocysteine can also converted into methionine when there is increased concentration of homocysteine in our body. Okay, so there is two things. Remember, you have to remember three things. Like the first is the enzyme. So it is a methionine synthase, or you can say it homocysteine methyltransferase. I just write short form homocysteine methyltransferase. We know that this is homocysteine. If you add methyl, then it forms a methionine. So enzyme is methionine synthase or homocysteine methyltransferase. Methyltransferase, who gives the methyl group? You know in the biochemistry that the one and only methyl donor, the most is at most of time is folate or folic acid. So folic acid gives methyl donor, and there is a requirement of vitamin B12 as a cofactor for that enzyme. So you can't forget these three things, that methyl synthase is an enzyme, folic acid act as a methyl donor, and B12 which is a cofactor. If there is deficiency of any one of them, it leads to increased amount of homocysteine because it cannot convert it into methionine. आगे हमने बात की कि जो मिथियोनिन है वो एसेंशियल अमीनो एसिड है, मीन्स कि it cannot produce in the body, and now we are talking that homocysteine can convert it into methionine, so it became essential. So it is not like that. I said that whenever there is increased concentration of homocysteine in our body, at only that time the enzyme act on homocysteine and convert it into methionine. Okay, because homocysteine, it is a protective mechanism, because homocysteine is, you know, that associated with cardiovascular risk. So whenever there is increased homocysteine, it can convert it into methionine. So high concentration जब homocysteine की होगी तभी ये enzyme काम करेगा. So you can also say that it has like low affinity, है ना. एंजाइम की एफिनिटी कम है, तो जब ज़्यादा कॉन्सेंट्रेशन होगी तभी ये काम करेगा. एंड यू कैन से इट हैज़ हाई कैम. So methionine synthase has low affinity and high CAM. Then there is a requirement of vitamin B6 and serine. It can convert it into, you can like homoserine and cysteine. So homoserine and cysteine is produced.